Hi, my name is François Normandin and I'm a LabVIEW architect and LabVIEW champion. Today I'm going to present you about the MQTT broker and the associated classes. This is a project that is hosted by the LabVIEW Open Source Project, and you can find all the information on GitHub. Okay, I'm gonna jump right into installing our project. So I've chosen to demo this MQTT broker into LabVIEW 2020, but it's going to work except for the TLS part on all LabVIEW versions all the way down to 2013 SP1. So no worries there, we've got you covered. First thing we're going to do is install everything, and so I'm going to open a VI package manager and just choose to install the broker in a moment. Okay, so all the packages have been installed. Those are the dependencies for the full project, and as you can see, the secure TCP connection was not installed. I'm going to keep that for a little bit later so that we can cut off the video. So for those that are not interested in TLS and certificates and all that. And now I still want to install the broker, so I'm going to use this VI package and install that. Luckily, it's going to be fast because all the dependencies have been installed already. By the way, everything is on the LabVIEW Open Source Project, well, as much as possible, is being licensed using the 0BSD license, which is extremely permissive. Okay, so everything is installed. Let's go back to LabVIEW 2020. I don't need those anymore. I'm really gonna start, super fresh, show you how easy it is to use this framework. We're gonna start directly from a blank project. I'm gonna call that MQTT Demo 2020. First thing I want is a server, right? Because you want to test your clients against that. And so let's explore the where the LabVIEW Open Source Project is set up. So it's in the under add-on LabVIEW Open Source Project, the MQTT. So MQTT contains control packets, the client and server, and all the connections. And let's go into the client server. So there's a base library here, which is, as you see, there's no constructor. This is on purpose. You need a client or a server constructor, and then your MQTT base is all the generic things that you might want to do, like reading the public events, starting and stopping, subscribing, which is something that the client can do, and destroying. And then you've got the client and the server, the broker. So the client can read public events specific to the client. You can connect and disconnect, see if it's connected, publish a message, or ping the server. And there's a bunch of drop VIs that we're going to use, which are, as you will see, very useful. Finally, on the broker side, you have a much easier, much simpler palette, which is just create server and read the server's public events. Again, there's a drop VI, and this is what we're going to use. So see how simple it is. Boom, I've got a server already. Now, you'll notice that there's a connection here at the beginning, and we're going to just leave it at that and change it later on. This, I don't know why it goes down this much, but you're going to have to find these few items, indicators. It's essentially just the number of connections. And what do I do? This is my server. All right. I want to have a client, and my client here is going to be a client that I want just to publish data. So let's go with the simple publisher. of data. And again, you see I've got the same object for the connection configuration at the beginning. I have almost the same thing, except that we do have a connection and a disconnection event that we're monitoring through this connect. And we can stop the whole thing. We are publishing on the topic, my topic name. I'm going to leave that, but you can change it to whatever you want, obviously. And I'm going to just change this to a control so that we can set the period at different value. So it's going to be 100 millisecond publish rate for now. I've put this, it's really just a random value, and I've put that on the form. So this is the client client 1. All right, and to finish everything, I've got this simple client subscriber, which, yes, you've guessed, exactly the same pattern, except this time not only does it connect, but it can also subscribe, unsubscribe, and I've added some indicators that will change if you get the acknowledgement from the server that you are indeed correctly subscribed. So, and this is about it. We would be ready to start, except we need to have a connection now. So the palettes, there is this MQTT connection. The connection palette here are generic methods that you can use. It's the public API that you can use to either have a client or a server through a listener, basically. And so what I'm going to do now is choose a configuration, let's say a TCP configuration for now. So all of these VIs, I think you don't need, except if you want to use these connection, raw connection palettes. So the configuration node is the same whether you will use a WebSocket. There's a WebSocket configuration, and there's a local queue configuration, which you could use if you didn't want to connect to the network. So this arrangement is so that you can extend the framework, the connection object, which if you override the right protected methods, you will end up with a TLS secured TCP connection, like you'll see when we jump into the TLS configuration at the end of this demo. But also, if you wanted to do, I don't know, MQTT over CAN network, or you can do it over network streams if you want. So all of that is possible, and you would then just use the connection at this point. All right, this is really all that we need. We need just specify that right now we're still on localhost, and you want to have a port. So the generic port for the TCP connection is 80 maybe, but the generic default port for MQTT unsecured is 1883. So I encourage you to use this, and you just need to replace like this, and this is it. So I'm going to use this to create a server that runs on the TCP and listens on the 1883 port, and I'm gonna just run the server and put it right up there. Client 1, which is my publisher. Sorry about this. We're gonna want to connect exactly the same place. So I want to connect to 1883. And let's see if it works. If I were to connect, yes, I'm publishing, and I can increase the speed maybe by dropping this, so 30 milliseconds, there you go. And finally, my subscribing client, and it's as simple as just replacing the connection configuration. The rest is completely abstracted away from under the hood. And there you go. I'm going to connect, and I'm going to subscribe, and yes, it's there. So if I were to disconnect here and reconnect, yes, my subscription works because my server didn't stop. So there's no problem. I can unsubscribe, let that run, resubscribe, and you see that it works. Disconnect, stop, and stop everything. There you go. All right, that's it for the demonstration. It's really as easy as that, and then you can explore other different clients if you want. Examples, I've got a simple pub sub, so you might have, you know, your nodes that are listening to commands and publishing results, and so definitely you'll need to merge both publisher and subscriber in the same application. There's a template for that. There's also a simple reconnecting publisher, and you know, just to show you how you can make sure that when the server leaves and comes back, or your own network connection goes down, you can just reconnect easily. It's as simple as automating the connect disconnect every, you know, retrying every second or every whatever time period you want. And finally, there's a more generic client right there, code, which shows you a bit more how to the different ways that you can decode. And so I'd like to spend a little bit of time on that. So essentially, there's a, you know, the MQTT protocol just specifies binary transmission of U8s, basically, on int bytes over the network. And so it's useful with LabVIEW to obviously just write anything on that payload. So what you're going to find into this built into the client is that it uses a serializer. That serializer for now is just by default using the flattened, unflattened LabVIEW node, which means that if you are on the other side and you want to decode and you know the type, then you're going to be able to do that very easily. This is something that can be seen if we go into the not the subscriber, but the publisher. So I'm going to close this. I'm going to go back to our client number one, which publishes. It publishes what? It publishes a double resolution value. And so, as you can see here, it's just a variant payload. Under the hood, what will happen is that it's going to serialize. I want to show that to you. So there's a serializer class that is default to the client and the server, and it just uses that to pass the bytes into a generic MQTT publish packet, and the rest is ferried to the connection. The connection is gonna just send those bytes over whichever connection you've decided to use. So obviously you don't see that here, but because I decided to use the default serializer, but you can definitely override the serializer and define it as you want. So I'm gonna want here to spend just some time to show you that I can move to a different serializer and it's going to work as well. So how to do that? We're going to need to inject into the client a serializer. So how to do that? You will go into your MQTT base and you have the get and set serializer. So we're going to just inject here a different type of serializer, which, as I mentioned, you can define your own type as long as you have the marshalling and unmarshalling of the data, which means, you know, flatten and unflatten, if you will, or serialize and unserialize, or deserialize, then it's going to work. So now flattened string is what is the default one, which is, you know, by default, we need a serializer. It might be, you know, to just take whatever. Okay, I'm gonna go back here. Okay, I will keep this this base open for your reference, but we're gonna go back into our add-on LabVIEW Open Source and the Open Serializer. You'll see that here I've got a couple of different serializer, and we use this serializer, which is just flattened LabVIEW code. If you wire a generic one, the default serializer, it's going to end up picking this one, which is built into the base the basic library. And so one of the things that you'll probably want to do later is to develop, let's say, I don't know, a JSON serializer or an XML serializer or your own encoding for your data. If you were to use a very lightweight byte, command where your first byte is the command, the second byte is the argument, and the third byte is just a checksum value or CRC, and you want to communicate with 3 or 4 bytes maximum to do super high speed and lightweight and low energy on your network. That's entirely up to you. So you're going to need to go and look into the Open Serializer here and essentially override 2 methods, the Marshall and non-Marshall. And by the way, I noticed today that I doubled the L in the word. I thought it was marshalling and unmarshalling, which doubles the L. But so sorry, it looks a bit weird for native English speakers probably to see a surname there instead of a actual English word, but bear with me, it's going to be fixed for the next in the future upgrade. All right, so you might want to marshal and unmarshal directly in binary. The only difference is that it takes it's a string that has been put into bytes. So essentially there's no change. It's really just so that you don't have to insert a string to byte array or byte array to string everywhere. It's really just a wrap around. But how it works is that you would take, for example, this node here, and I want to flatten something, and that something, well, it has a type, and so if you know that type on the other side, well, you can set the type, and when you receive those bytes, you're gonna then get variant to data. You might be wondering why I don't use malleable VIs. That's because the base code that it's released in is still 2013, and so malleable VIs are not yet part of the equation. But as an exercise, if you want, you can probably override these and this base and just wrap these Marshall and non-Marshall methods with a malleable VI, which would give you something much easier. And so if I were to do this, you're going to see that, where's my data? My data is there, so I should be able to see very easily, that yes, I can flatten and unflatten easily. So this is how it works. If you want to write your own serializer, make sure that the serializer for the server and your client is the same, and voila, it's going to work. I could go through the process here, but I don't have anything smart except maybe the serializer, which is a plain text serializer, and the plain text serializer has some hiccups with if you don't provide a good name or things like that. But essentially the most flexible serializers you could find out there are the ones that take more time to serialize, more CPU, JSON, for example, or XML, that might be much more open to a wide range of types. Now the LabVIEW flattened string serializer is going to be very powerful for you, provided that you have the exact same type on the other side. So it might cause you some pain if you publish data with a single float resolution, and on the other side you try to decode it with a double value. So you're going to need to conform very strictly. Sorry. You're going to need to conform very strictly to the type, but it's still going to work for very complex types such as clusters and arrays and clusters of arrays or arrays of clusters. No worries about that. As long as you have the exact same type, it's going to work. So I definitely encourage you to develop your JSON or XML packets here. I think on the VIPM right there's if you look for the Open Serializer, you're going to find that there's a base 64. So maybe I'm going to do a demonstration using that right here. So let's install that. Okay, so my base 64 has been installed and compiled. Let's see what happens. Unfortunately, I don't think that I've put a class drop VI like this, but still, there you go, base 64 encoder, and these are really fast encode and decode that are wrapped, but you don't see it, but they inherit from this Open Serializer. So if I want to get in and find my class, I'm going to use this. You see, it's really just a wrapper around it, and I'm going to reuse this base class. So if I were to set a base 64 right here, I can do that. And if I were to do the same thing in this second client, now they can talk to each other. Now you're going to notice that I don't need to go into the server to do the same, because, well, the server just deals with packets, with binary data. So it's really for the clients to know when they talk to each other, what is the protocol that they use for decoding the payload. So I'm going to restart my server, and in C here, pop. Do I have my client 1? It's there. Right, I can connect, publish, I can connect, subscribe, and yes, indeed, I do see that data. So now the data has been encoded differently, but it's all propagated through the same means, through binary strings, not binary strings, binary streams, sorry. So that's one of the main advantages, I think, with using this MQTT library or set of libraries, is that you can really configure it to whatever you want. Change the configuration for the connection, boom, you're on a different protocol. Change the configuration for the encoder, boom, you're on your own encoder. You can encode and encrypt. You can do whatever you want, and your framework is really as flexible as I think it should be for your own application. All right, now in this next section, I'd like to show you a bit around the connections. So we're deep diving a little bit more. We've seen the classes, the MQTT client and server classes. Now let's go down one level and see the connection. So if you were to not care too much for my implementation of the client and server, but still want to communicate very lightweight on over MQTT protocol, you can do that with connection, and even then, if you don't like my connections classes abstraction, you can go down and use the packets directly to implement your own own messaging layer. So I think what I'd like to do is just open an example that is straight into the palettes, and these are probably the best place to start. Whoops, sorry. the best place to start, because you've got the equivalent of a server at the top, where I have a listener. In here, I'm not doing that into a loop. But if you wanted to have an end connection handling, just put this listener into a loop that generates a connection asynchronously through maybe VI server or whatever framework you want to use, actor framework, JKI state machine objects, DQMH, or the messenger library, or the workers. There are plenty of actor type process generator out there, and so that would be, I think, very, very simple for someone used to one of those frameworks to spawn an end type connection server. If you don't want to use the server implementation that we've just discussed. And at the bottom, it's your client infrastructure. Now here, there's only one client, obviously, because there's only one. The listener will just shut down as soon as it receives its first. But you see how simple it is. We connect based on the configuration that we've set. We check if it's connected. We can send some bytes and wait, query for some bytes, and that's it. So here, I don't even use the open serializer classes. I'm just flattening the data, unflattening the data, because I know what's coming up. And the server, as you can see, doesn't need to unflatten and flatten. It just echoes back here. Of course, for your own MQTT server, you would redirect those messages to the subscribers, which is, again, you don't need to do if you use the MQTT server that was just presented. Okay, so you can just run and spawn a new connection every time. Obviously, this is not the way that it should be used. You should have one server that accepts multiple connections and just closes all the connections as soon as a client leaves memory. But you see the point. Now, what I'd like to do is to show you the WebSocket connection, which has also an example. And the example, I hope you'll appreciate how very, very similar it is to the other one, except that, yes, I've just changed the port and changed the node, which is configure WebSocket connection. And essentially, it's the same thing. So there you go. There's a local queue connection. There's also an example. All very boring. We just need to define a queue name for the client to connect to the server, and under the hood there's going to be a handshake being done to generate a new randomly created string, which will be a unique connection that only the server and the client knows about. And so the local queue connection is going to drop out of the MQTT local, and MQTT local is essentially used as a service name, if you will, for local connection. Now, I definitely encourage you to dive into this particular implementation if you want to create your own, because I've implemented some sort of very, very crude HMAC handshaking, where the server will connect, will allow the connection only if the client has the right credentials, and you can basically do that handshaking back and forth, which is what the TLS, is doing in the background for you. These libraries that are there, or that the WebSocket connection API does for you in the background. It's going to handshake and upgrade your connection to a different protocol. So definitely look into this particular implementation if you want to get some inspiration into that. But they run exactly the same way, and you can even run them super high speed if you want, which is probably not useful, but definitely that works. Okay, so this is for the clients. I mean, for the connection. As you can see, there's the basic nodes. You want to see if there's a connection timeout time, get a reason. So get reason text is something that I've had it here, so that if you want to give a reason for a disconnection or for protocol violation, there's a bit of an override in the connection class that allows you to specify an error message and a reason for whatever has happened. And so I encourage you to just look at the code if you're interested in that. All right, the last thing that we want to explore, I'd like to explore the control packets now. So control packets, again, under the MQTT control packets, and this is a very, very generic library of low-level nodes that you might want to use for your own implementation. If you want to communicate with the MQTT protocol, but you don't recognize yourself in the connection or the client or the server implementations that have been proposed to you, this is the absolute low level MQTT control packets that you might want to use. So there's a polymorphic VI which might be very useful for you. You can see all the different payloads if you're you want to connect, and then when you've received the connect packet, well, you'll see that there's a byte stream already there, so you can just set out all the flags, payload for connection, generate your client ID, supply your client ID, do whatever you want, keep alive, and it will generate you directly the byte stream. Now, you can also go into the different connect packet, where if you want to explore what are the connection flags that you've set, you'll get that there. And so let me just complete this. If I set this one, clean session is true, so very simple API. You can see all the control packet, more generic, everything that a control packet has in common with all the other packets, like a publish packet, a subscription acknowledge packet, a ping packet. They all have a few things in common. One is if you want to get the byte stream, know if the packet is invalid, or validate, because you can just set that to true, and you'll know if the packet has been is invalid. You also have a validate packet node that will give you an error if it's invalid. You can prepare a response in certain cases. For example, when you receive a publish packet, if you're the client and you send that to the server, well, the server will want to prepare a response, and so that response based on the QoS will differ. So if you are on the quality of service of 1, you're expected to reply with pub-ack packet, and that pub-ack packet will be with a packet ID that matches the packet ID of the publish packet. Well, you might want to go in here and say read the packet identifier, extract that packet identifier, and note that, oh yes, I want to get the flags, and so these flags will tell me what is the quality of service that is requested, and if it's a quality of service requested 1, then it's a pub-ack packet. So all of that is included into the actual respond, and you'll get a control packet here that if I read its packet type, you would see that this is a pub-ack. But if I were to change quality of service to 2, it would be you expect to have a pub received as the response. And if you're on the other side and you receive a pub receive, well, then you expect that the control packet type is going to be a pub release. Let's see if that works. There you go. So these things are all handled. If you have a quality of service, it's going to be reserved because it's well, yeah, it's going to error out because it's invalid, right? There is no packet ID with an invalid reserved packet here, which is, don't use that. That's the default. And the framework, not the framework, but this palette here is going to tell you that there's a problem with that. So other thing that you'll notice, there's a MQTT 3.1.1 constant, and this is because in the future I want to have a MQTT 5.0, which will allow us to add another packet type, which is the auth authentication packet. You'll see that it's already listed there, but in MQTT 3.1 it is a invalid packet, so this will error out. Basically, it's important to know what is the protocol that is supported by the server and the client, and when they talk to each other, they need to be on the exact same page. So currently the server and the client, they only support 3.1.1. So although 5.0 is part of this packet, it is not yet available and shown in the palettes because I prefer that you don't mess with that. Now, there's another cool utility and you can find it right here. It's where you can append incoming bytes. And so append incoming bytes is essentially the way that that you're going to use to take all the bytes that arrive from your TCP connection, network stream, WebSocket, whatever you want, or even a queue, a local queue, and you want to extract very quickly the packets out of there. So I created this drop VI that essentially is a demonstration of what you can do. Let's go through that. What you see here is that there's a loop where you would be receiving some packets, all right? And I show that as, right now it's a queue. What you probably want to do first is to have your own, connection that arrives here that will read, let's say, from TCP. And so just for the sake of it, I'd like to demonstrate a write of a single packet, just so that it goes, it's being detected on top. So I'm going to use the connect packet, and that's it. And I'm going to terminate that right away. Okay, so that there's only a connect packet that is being sent. And what I want to show you is that here, right there, we're going to handle and receive a packet of type connect. And that packet of type connect is going to have, is going to be exactly the same as this payload. But that's not the point here. What you'll notice is that when bytes arrive, you'll probably have a session, and this is probably a representation of your private data that you want to keep. All right, so if you are developing your own application using directly the control palettes instead of the connection and the client or server architecture that was shown in the MQTT broker project, if you want to use directly here, you're going to need to have private data. So your private data is going to be whatever sensor value you want to keep, or commands and decrypting and whatever session parameters that you have. So think of this session, MQTT session here as if you're using, for example, a JKI state machine, that would be your private data bus that you keep your data on. So in this case, I'm going to ignore it completely, and the only thing that I want to show you is that whenever you receive data from somewhere, it's going to show up right here through this very simple incoming decode incoming or append incoming byte. It will take whatever incoming bytes and output a packet whenever it's ready and whenever it's full. And if it's not full, it's going to just send the bytes on the data bus and append them essentially to what's coming. So you don't have to wait for a full frame. You could do a very, byte by byte, very simple communication that is completely dematerialized. You could be losing your connection in between, reconnecting and continuing to send your bytes, and that would still work. So this node will decode based on a certain protocol version, and the protocol version that is shown here is 3.1. So this would be your equivalent of a server, essentially receiving data from a client that is remote and sends your connect. All right. And yes,